Top right corner, there should be like numbers now. I think it's counting. Yep, okay. All right, here we go. Where are we? Alcohol, ether, halide. All right, so aldehydes. So aldehydes. All right, so aldehydes. The phrase that my chem teacher told me in high school was "Yo cho, Al's my pal." I told you that already, right? I didn't? Yo cho, Al's my pal? No? Really weird phrase, I know. And the reason he said that is because we didn't have table R. We had to memorize all these things. So we had to, if you look at the aldehyde, so don't look up here, look at table R. Look at the aldehyde functional group. He called it the CHO group. CHO, C-H-O, so yo cho, how he would say it. And Al's my pal, why did he say that? Because if you look at the name of the aldehyde, it says propanal. That's how you're supposed to say it, propanal, not propanol. So he would say, Al's my pal, to get us to remember how to say it correctly. And it ends in A-L, like Al. So propanal is how you would say that. So you don't really need the phrase because you have table R, but it's kind of funny. I always share that he was always saying some weird stuff. So anyways, aldehyde has the C double bond OH group, so the CHO group, and propanal is the example. Jenny, why is it called propanal? Why is it not butanal or pentanal or methanal?
Because there's three.
Three what? You're right, three what?
Carbon.
3 carbons is prop. And it's called, or ends in Al because it's an aldehyde. So really it's just propane, but you put on the C double bond OH there, and that's propanal. So it's the same, concept as the alkanes. Count the number of carbons, use that prefix, but then you just have to end in Al. So if I was to write that on the board, or this one here, can you name those? So write them down and name them. The purpose of the notes is going to sound weird, but isn't really to learn this stuff. It's just to get examples. So when I give you have one worksheet, there's going to be another one we do. When you work on the worksheets, you can use these to kind of help along with table R, and as you're doing the worksheet and when we go over it, that's when I think you'll learn. This is just to get it down, get some information, maybe pick up a little bit here and there, but really the practice should be the clincher. So table R has propanal because there's 3 carbons. I gave you one with 1 carbon and I gave you one with 5 carbons. So obviously they're not called propanal. They're called something else. Jake, what do you think of the first one? What's the prefix for 1 carbon? Meth. Good. So it's meth. And then if you look at the example on table R, see what comes after pro. Then just put that here. So if you look at table R, look at the aldehydes, look at the example, it's pro. It's methanal, that's how you say it. Methanal, methanal. Meth because there's 1, A-N-A-L, methanal, right? Al, that was the whole thing with my teacher there. Al's my pal. So methanal because 1 carbon, and this is your functional group, so it's an aldehyde. Edmund, what do you think of this one? Pentanal, there you go, pentanal. Okay, again, Al's my pal, so we don't say pentanol. Pentanol would be an alcohol. Pentanol would be that, O-L. Pentanal ends in Al, A-L. Okay, that's it for aldehydes. Next, ketones. Ketones are very similar to aldehydes, except there's no H, it's just the C double bond O. So ketones have that C double bond O. And Kristen, what do they end in? What's the name ended for ketone? Just give me the letters. Just tell me the letters. O-N-E, right. So ketones end in -one. That's how we say it. So if you look at the example on the chart, it's 2-pentanone. That's how we say it, 2-pentanone. Taylor, why is it 2-pentanone? Good, there's 5 carbons, so it's pentanone. Pent, very good. What's the 2 for? The thing, what thing? The double bond O is on the second carbon, so that's called 2-pentanone. If we shifted that double bond O over 1 carbon, what would it be called? 3-pentanone, right. So the number tells us where that double bond O is. So, try these. Oops, let me do a structural for you here. So what if we have... So copy that and name it. And what if we do this over here? Again, like I said the other day, the most important part is can you look at these two and tell me they're ketones? If you can do that, you're in a good place for most questions. Sometimes they will have you name these things. But it's not every year. Sometimes they're easy, sometimes a little harder. It's tough. It's tough for me to get you ready for that. So I cover it all, but most of the time it's really just identifying what functional group. Or they'll give you the name. So they'll give you. So they'll say, all right, given this, which of the following is the correct name, and they'll give you 4 choices. I feel like that's easier than just coming up with it on your own. So at least you could, look at the answers and say, oh, okay, that makes sense. Hopefully. All right, what about that first one, Evan? 3-hexanone. Very good. 3-hexanone. 3-hexanone because 1, 2, 3, 4, 5, 6. That's hex. The O-N-E ending for the ketone, and the third one has the double bond O. Good. All right, what about this one over here, Ryan?
I didn't name it.
What?
I didn't name it.
Yeah, I know. I'm asking name right now.
Okay. So
If this one is 3-hexanone because that's on the third carbon and there's 6.
This one is 2.
2.
And then it's 1, 2, 3, 4, 5. There's 5. So pent. What is it? Pentane?
Pentane is an alkane. This is a ketone.
Oh, okay. So
Yeah, look at the example.
I don't know.
The example should really help.
Pentone.
Pentanone, right?
Pentanone.
2-pentanone. It's the exact same, but I just drew it flipped. Okay, I did that on purpose just to see if you guys would pick up on it. So if I took the example from table R and flip it, it looks just like this. Okay, so 2 and then pentanone. 2-pentanone. All right, done with the ketones. Next, organic acid. Organic acids are much more common. The Regents likes to ask about organic acids and alcohols. Why? Because they have something in common. Devin, what do organic acids and alcohols have in common? OHs. Very good. Organic acids also have OHs. So, Bree, what did we learn about alcohols besides how to name them? You can look in your notes from yesterday. What else did we write down about alcohols besides how to name them and draw them?
They have
High boiling points. So do organic acids. Higher boiling points due to hydrogen bonding. And they have hydrogen bonding because they also have, sorry, that's really messy. They also have OHs. Who remembers the other 2 elements? Chuck does. Besides O, what's the other two that can do hydrogen bonding with H?
Nitrogen and fluorine.
N and F. Very good. All right. Higher boiling points due to hydrogen bonding. Also slightly polar. Slightly polar. So, Xavier, if organic acids are slightly polar, they will dissolve in what? Water. Yes. Who eats salads in here? What do you put on your salads? Not the vegetables, but what do you put on top of the salad after it's put together?
Milk.
Dressing. You said milk?
Nah, it's just something else. But it's okay.
You were going to say what?
Cottage cheese.
Oh, cottage cheese.
A
That's fair.
whole gallon of it. A gallon of cottage cheese. I can't
Gallon
taste
of
it.
cottage cheese. Yeah, dressing. What's in dressing that people like the taste of?
Ranch dressing.
Vinegar. Usually vinegar in a lot of dress. Vinegar based in a lot of dressing. Why am I talking about vinegar?
Because it's an oil. No, it's not.
It's an organic acid, right?
It is an organic.
Vinegar is an organic acid. You can dissolve vinegar in water. In fact, I know at my house we use vinegar to clean things. Windows, floors, we have hardwood floors. So you take a little bit of vinegar, a little bit of water, more water than vinegar, and it's good for cleaning things. Actually, you clean a lot more than windows and floors with it because it's an acid, so it kind of eats away at things. So anyways, vinegar is an example. I like to just tell you that because a lot of these, I can't give you something that you're going to see in real life, okay? But this you will, okay? Vinegar, everybody knows what vinegar is, or you'll eat it or come in contact with it sometimes. So anyways, organic acid is vinegar. I'll draw you the compound here for vinegar. Wait, I want to make sure I'm not forgetting something. Hold on. I feel like I'm forgetting something. Talking about vinegar, forgot what I was doing here. No, I guess that's it. So anyways, here's the structure for vinegar. Go ahead and write this down. Use the example on table R to name that. I just told you it's vinegar. Vinegar is like the real name. I want the chemical name. So you're going to use the table R there to help you name it as according to the chemical rules, not just regular people rules. So go ahead and name that one, and then I'll draw another one over here, and you can name this too. Underneath this one, I'm going to write it a different way, just so you can see the different ways you might see it. So go ahead and try and name those two using table R. So good. This must be easy or something. Everybody's getting it. Jenny's on the right track. Jake's left leg is hot. That's right, yesterday I had to go somewhere and I went home and changed. I put jeans on for some reason. And I was sweating so much I rolled the jeans up. But I was in my car, so.
I hope that's fresh.
I had them up to my knees. I looked like a total tool, but.
You probably look cool.
Yeah, I was.
like
I was
polo
not
shirt?
as hot though.
Were you wearing like a polo shirt?
T-shirt.
What
I should wear shorts. I lost my mind. I don't know what I was doing. All right, back to this. Everybody got it. Very good. What is it called?
2-propanonic acid.
Almost everybody got it.
You just said everybody got it. Wait, what?
I couldn't really see exactly. I was looking
How
at
is it
both of
not?
them.
How is it not? Oh
What?
my god, I completely.
So change it.
I don't want to talk
Yeah,
about it.
you got it. You got this. You're in the special seat. You got it.
No,
So it's not propanoic.
It's meth. It's 2 meth. No, it's F. It's F.
Why is it F?
Because it's 2.
2, right. So it's, good job. So what is the name? Ethanoic acid. That's ethanoic acid. It's also called vinegar, but ethanoic acid is the chemical name. And of course, me being a chemistry teacher, in my brain sometimes if I'm at a restaurant or someone says something about vinegar, I'm always tempted to say, no, I'll have ethanoic acid. And that's like a super dork thing to say, but they would just be like, what's wrong with you?
They'd be like, oh yeah, no problem, right away.
Yeah, maybe they would. Maybe they'd be chem majors or something. I don't know. But anyways, there's another name for it. It's called acetic acid. There's 3 names for it. Vinegar, ethanoic acid, acetic acid. You don't need to know any of them except this one. Okay, so you need to know how to name that as ethanol. Over here. Nicole. Butanoic acid. Very good. Butanoic acid. Good job. Butanoic acid. There it is. Okay. So these are real common on the reagents. So are alcohols, because then they can ask not only how to draw and name, but they can ask about this. All right. They can say, okay, explain why this might have a higher boiling point, and that's because of the hydrogen bonding. All right. So that's it. There's only one real one left I want to talk about. Esters. I think I'm going to skip amine and amides this year. They're sometimes on the reagents, but really all you need to do is be able to use table R and recognize it. So I'm not going to waste time just writing something down you're not going to really look at again anyway. So I'll just leave the amines and the amides up to the worksheets. We'll talk more about it when we go over the worksheet. So we're just going to focus on ester, and then I'll let you work on the worksheet. Esters are difficult to name. They're much harder than any of the other ones to name. And I'll do the best I can to try and show you how to do it, but I think just practice will help. All right, so we'll go over it right now. Oh, and there is one more group that isn't on the reference table, but you learned about it. You learned about it in biology. Without these, you can't make proteins. Yeah, amino acids, right. Guess which 2 functional groups you need together to make an amino acid? An amine. An organic acid. So that's what an amino acid is. So I'll show you a quick example of that, and then we'll get to the worksheet. So here we go. Let's talk about esters. And I think I already told you this. What's special about esters? Anyone remember? Yeah, they have odors. Good. So esters produce odors. And usually the odors are pleasant. Sometimes they're not, but most of the time they are. So things like flowers, fruits, perfume, cologne, which is how I remember to spell it. Body sprays, deodorant, almost anything that has a laundry detergent, dryer sheets, almost anything that has an odor probably has an organic compound responsible for it, and it's probably an ester. There are other things that produce odors, and I probably don't know of all the things, so I'm not pretending to be an expert, but I do know esters are used in a lot of things. So things that smell like bananas or taste like bananas, but they're not actually bananas. So like, I don't know, juices or candy or whatever probably have esters in them. In lab, I'm debating whether or not to do the lab as a demo or to do it as a lab. We'll see. But either way, you're gonna experience it. We can make 3 different esters. One smells like bananas, one smells like peppermint, and one smells like it's called fruit essence. It smells really weird. It's kind of like a sweet but nail polishy smell mixed.
What?
Yeah, it's kind of like nail polish with sweetness. It's kind of gross.
Sweet nail polish.
Sweet nail polish, kind of. But
That's great.
anyways, yeah, the banana one is cool. So you mix all these chemicals, and you heat it up, and you do this and that, and you take the top off, it smells like bananas. It's pretty cool. You really don't expect it. You may not even believe it, but when you smell it, you're like, whoa, it smells just like banana. Like if you close your eyes, you think you're smelling banana. It's kind of cool.
Bet you doesn't.
Apparently KFC.
Oh yeah, I heard about that. They made edible nail polish.
Edible nail polish.
Ew.
That's great, dude.
I guess it's good.
So say
It's
say you
not
get the
food. Don't eat anything that's not food. That's my advice to you.
But if
No,
you
so
bite
say-
your nails, then you won't cut yourself.
Wait, time out. What?
Like if you bite your nails, you have nail polish on. It's
Well,
like
you
better.
wouldn't die.
Yeah, but it would be better.
I get it. Yeah, I guess it's better.
Well,
for you to
technically,
eat.
you know what they made it for? So say you're eating a nice chicken leg, and you get some of it on your hands, you go lick it off. You still eat the flavors. That's the reason.
I think that's a waste of resources, but anyways, back to this. Esters, yeah. So this actually is on the Regents sometimes. Which of the following compound can produce pleasant odors? You got to pick the one with the ester group. What's the ester group? C double bond O with another O. So on table R, it's right there for you. So I'm going to draw or put two of them up here. I'll explain. Let me back up. Let me put the one in the reference tables on the board and explain how they came up with the name, and then we'll go from there. So the one on the reference tables, you can just watch if you want, or write it down. It's up to you. But yeah. So we have CH2, then we have a C double bond O, and then CH3, right? So the name of this is methylpropanoate. So let's say that again. Methylpropanoate. What's methyl mean?
There's one.
One carbon. What's prop mean?
There's three.
Three. So I'm going to put a box around, no I'm not. I'm going to, I always think of different ways to do this because this is hard for kids and I need to get better at teaching this. So I try different things that might help. What if I covered up the oxygen here on the right? So what if I just kind of did that? Does that help you see where there might be three carbons together and only one carbon? Where's the one carbon? On the right. Where's the three carbons? On the left. So now look at the name again. Methylpropanoate. So which carbon up there is the methyl? The one on the right. Where's the propanoate? On the left. That's how you name esters. Every time. You find where the carbon is. Oh, kind of sliding there. You find where the carbon is on the other side of the oxygen. I say the other side because here's the double bond O. So I really, you're looking here. So this carbon and to the left is always going to be your O8. That's your O8 part. And then over here is going to be your YL. So that's methyl, ethyl, propyl, butyl, whatever. This over here is going to be your methanoate, ethanoate, butanoate, propanoate, pentanoate, hexanoate. So all the O8s are attached to the carbon with the double bond, and all the YLs are going to be on the others. I say this, this is how I say it, the other side of the oxygen. That's going to be your methyl, ethyl, propyl. It's not easy, but that's kind of where you're looking. You're looking here, and then kind of like the left and the right. The right side here is going to be your YL. Left side is going to be the O8. So if you can kind of get that straight, at least right now, let me put two examples up, use that format, and see if you can name it. The problem is these things really exist, and the Regents sometimes doesn't always draw it the same way. Sometimes they put this O on this side of the carbon, and then it's throwing you a curveball, so you have to kind of reverse it. So that's hard, I get that, all right? But let's first do it this way. I'll draw two the same way we have it here, C double bond O, and see if you can name it, all right? So let's try that, and then we'll go from there. All right, so let's go with there's that one, and then another one over here. All these markers back. Let's do C double bond O. So again, find, or maybe what I did, cover up that oxygen, and then name the right and name the left. You just got to remember which one gets the O8 and which one gets the YL. actually multiple names for these too, but you don't need to know them all, so I won't confuse you. Just how chemistry is. Where are we? You know, I'm done. How many carbons is that? One, right? Okay. You're right. That means one. What you got?
I zoned out for a sec. Well, I got it.
So I'm going to put a line through that O here, and then through this O. Maybe that's another way to kind of do it instead of covering it up. So to the left of the O and to the right of the O are two different names. So we have 2 here and we have 2 here. So we know this is F. We know this is F. We know this is 3, so that's prop. We know this is F because there's 2. So maybe that's another way to start it. You got to, at some point with this thing, this stuff, you got to memorize something, right? So maybe you memorize, okay, I put a line through the O, now I look left and right. Maybe that'll help. So there's your F. Here's your F. So we know it's going to be F and F, the two parts of the name. This is going to be prop, and this is going to be F. And now you just need to remember what I said before. It's not easy, but which side gets the OH, which side gets the YL? This one it doesn't matter because they're both F, but let's pretend it does matter. Edwin, which side is which?
The left is the 08.
Right, so this is your F and O8. This is your FO. So then you put it together, ethyl ethanoate. That's the name of this. Ethyl ethanoate. Ethyl ethanoate is the name of that because there's 2 here and 2 there. Over here, this is propanoate, and this is ethyl. So this is ethyl propanoate. Ethyl propanoate. And I told you they were hard, so I don't blame you if you're having trouble. Questions? No? No question. Good? Good? Ray, you guys good back there? Jake? Okay, I'm going to stop. Take out that worksheet. Got a little bit of time. Let's use it productively here. I am tempted to let you work with a partner, but not that tempted. So work on this on your own. I'm going to walk around and see how you're doing.
Work on what?
This worksheet I gave you yesterday.
Oh, okay. I thought we were going over this worksheet.
Yeah, I want to do that too, but
That's what I thought you were talking
yeah, I'm gonna wait. We're only missing 3 people, but I'm gonna wait. Yes.
I need that worksheet.
Come on up. So we'll do that in lab, Ryan.
Oh, yeah.
So the sheet you're working on now, due tomorrow. Remember, I'm gonna read the answers, but we won't really